So friction is simply a force, right, which opposes the motion always, which opposes the motion of an object when in contact with a rough surface. There should be a rough surface so that when two surfaces rubs against each other, like when you take your hand and you rub like this, you will feel the friction, and due to that friction, you will feel the heat. Whenever there is a friction, there will be some amount of energy dissipated in the form of heat. So if you look at this, if this block is moving against this surface, at a very microscopic level, the surfaces are rough, and I am applying a force in this direction. So the friction has a tendency to stop this object, to oppose the motion. So it will act in the opposite direction. And as a result, the friction is of two types. The one is called static friction, and the another one is called dynamic, or you can say kinetic friction. Now, if you look in your formula sheet data booklet, you will see there are two formulas given for the friction, right? So static friction is given with F as, I will say Fs, and this is nu as into Fn, where Fn is the normal force. This is for the static friction. What does that equality sign state? We will discuss that. And F, do not get D as the drag force. Here I'm stating the friction drag, friction dynamic as nu D into Fn. Now, nu is simply the coefficient of friction, coefficient of static friction for this. That is nu as. Similarly, nu D is nothing but coefficient of kinetic friction. So no need to worry about it. You will get it clear when to use which formula. But one thing for sure, you have to remember that the coefficient of static friction will always be either greater than or equals to, in some cases, to the coefficient of dynamic friction. Dynamic coefficient can never be greater than the static one. And this will only act when two surfaces, please do remember this, it only acts when two surfaces are in contact with each other. If two surfaces are not in contact, then the friction force will never ever exist. Okay. Now, just observe this graph carefully. So this is friction force on the y-axis, applied force on the x-axis, right? You can see that if I'm applying a force, right, the friction force is continuously increasing. And that is the reason I would comment here the one of the most important statement: when an object is at rest. I'm not talking about when it is moving. I'm only saying when object is at rest. Rest means it is not moving, okay? Then the friction is a self-adjustable self-adjustable force. Now, what do we mean by self-adjustable force? We'll discuss this with a simple example. But let us say this till here it is not moving, and this is the maximum static friction a object can act. So let us say I have this rough surface, right? So this is a surface, this is a rough surface, okay? And I am placing, let us say, this object. So you can see I'm inclining it, and there will be let me take any rough, and eraser is a good example because eraser has a very rough surface. Okay, so can you see an eraser capped on this? So I'm inclining it, it is not moving. So what is stopping this eraser to move down? So as I'm increasing, the friction is also increasing, but there will be a point now you can see it is moving. So
Yeah.
it can oppose up to a certain limit only, right? And that is why you see in the formula it is mentioned as less than or equal to. It means if you are applying less force, the friction will be less. If you are applying more force, the friction will be more up to when it is at rest. Once it start moving, you can see the nu d is less than nu s, so automatically this force decreases, friction force, and you will have a less dynamic friction. So don't worry about this. Let us take few examples so that you will be more comfortable what I mean to say it is a self-adjustable. So let us say there is an object on a horizontal surface. Let us say the mass of this object is 1 kilogram. Take G as 10 as of now for easy calculation. And let us say nu S will be 0.2, nu D is 0.1. And I apply a force on this block in this direction. Now, and the F applied, this is my applied force. So F applied, let us say 1 Newton. Okay. Now I have to find out, calculate, calculate friction, calculate the friction, and if it moves, right? If it moves, find acceleration. I have to find acceleration also. So first step, always remember while doing such type of problem, your step one, please do with step by step so that you will never ever will have any problem related to any of the question. So step one is always draw a FBD, the free body diagram. So I know that this object is kept on a horizontal. So the weight is acting downward, the normal force is acting upward. F applied is here. And if I'm applying a force, this has a tendency to move. But due to rough surface, the coefficient of friction are given. A friction force will act, right? So if I want to draw free body diagram, this is F applied. This is my mg weight. This is my normal force and this is my friction. So this will be my direction, free body diagram, right? Now the second step, step two. Once you have identified all the forces, second step is find the normal force. Because if you look in the formula, this is your normal contact force, right? So we need to know the normal contact force. So how we will find out normal contact force? There is no up and down motion, right? In vertical direction, there is no motion. It is only moving in horizontal. So in vertical direction, if there is no motion, can I say mg is equals to Fn? Say yes or no.
Yeah. Yes.
So mg is equals to Fn, right? Now in the question, I already gave you mass and g, so I can find out Fn. So Fn comes out to be 10 Newton. So this is my second step to find out the normal force. Quite easy. Now, third
Yeah.
step is step 3 is find F maximum static, the friction that you have to find out the maximum static friction. And F friction maximum is equals to nu s into Fn. Look here, that's the formula given in your data booklet. This is given in your data booklet, both formulas, right? No need to worry about it. So maximum, it can be less than this, right? So maximum is what? Maximum is equals to this. So I find out the maximum nu s into nu s is given in the question as 0.2. Fn we already find out 0.2 into 10. So this comes out to be 2 Newton, right? So this is a step 3 to find out maximum friction. Now, step 4 is very important to understand. What is step 4? Now, what we have to do is we have to compare the F maximum, the friction maximum with F applied, whatever the force is applied. How much force we are applying? 1 Newton, right? How much is
Yeah.
the maximum force? 2 Newton. So, there will be two cases in this. What are the two cases? Either it can be that F maximum is greater than F applied, or F maximum can be less than F applied, right? So if it is, in our case, what is happening? This 2 Newton, which is the F maximum, 2 is greater than 1, 1 is the
Yeah.
force applied. So in this case, it will not move. It will be at rest. Because, and if it is at rest, it is a self-adjustable force. So you will not say that my friction is 2 Newton. My friction will be equals to applied force. The friction will only apply till how much force you are applying. So I am applying a force of 1 Newton and the object is not moving. So the friction will also be 1 Newton because that's the only reason it is cancelling out and it is at rest. If maximum is 2 Newton and this is 1 Newton, it is not possible for this block to move in this direction because friction cannot be 2 Newton in this case. It is equals to the applied force. Are you getting it, what I'm saying?
Yeah.
But if my applied force is greater than the maximum friction, it means it will move. And if it moves, then I will use the formula nu T into Fn, dynamic coefficient into normal contact force. And then I will use F net, that is your driving force minus resistive force. So F net is mass into acceleration, driving force is your applied force here, minus resistive force is your friction force. This we'll discuss in a while, but let us first focus it here. And then you can simply say step, this is step 4, then you can say step 5 is simply answering, calculating friction or acceleration accordingly what they are asking us to find. So in this case, friction is nothing but 1 Newton and acceleration is c. So this is my final answer. So let us look at once again what was the question. So you understood what is the self-adjustable force, right? So instead of F applied, if I keep 1 Newton, instead of 1 Newton, if I keep 1.5 Newton, then what would be the answer to the friction? Till it is 2 Newton, it will be friction will be 2 Newton, acceleration will be C. Because it can resist the force till that point. Say yes or no. Okay, now I'm giving you a question and I want you to solve, and then we will continue it in next class. Try, give it a try. Be quick. Rest all things are the same. Okay, look here in this case. Now it's quite easy to understand here. It is the same step 3 till step 3, it is same. So I know that it is moving now, right? So if it is
Yeah.
moving, then friction formula will be nu d into Fn, right? Nu d is 0.1, Fn is 10. So Fn, we calculated it, right? Fn is 10. So nu d is 1 Newton, right? Now the friction
Yeah.
is 1 Newton. Now if my friction, so this answer is 1 Newton. Now I know that it is moving. So moving means I have to find out acceleration. So for acceleration, I use F net equals to driving force minus resistive force. Driving force is F applied, resistive force is F friction. F net is mass into acceleration. Mass is 1, acceleration I have to find out. F applied is 4 Newton, friction is 1. So that is 3 meter per second square. Simple. So these are my two answers. Is it clear now?